Good evening. Yes, so that's the first reminder. We're recording today, so if you have friends who aren't here today and still want to see this event, they'll be able to see the recording at the Williams website. So welcome to everybody. It's great to see everyone. My name is Shui Wang. I'm class of 96, and on behalf of the Williams Asian and Asian American Alumni Network, it's my pleasure to kick off our first online Mid-Autumn Moon Festival event. To give you a rundown for the night, we're going to start with a quick explanation of the Moon Festival and the legend most commonly associated with this holiday, and then move into a short moon trivia contest. I'll be explaining how to participate over CrowdPurr. This app works best if you have a second device, so if you don't have one near you right now, this is a good time to get a second phone, an iPad, computer, whatever. Keep in mind the honor code applies to the trivia contest, so no looking up answers. And the winner of the trivia contest will receive a mooncake from Chinatown. I'll mail it to you. And then after the trivia contest, we'll hear from Kevin Flaherty, a lecturer in astronomy and observatory supervisor at Williams, who will give a presentation about the moon. He'll explain some of the trivia contest answers and show us some pictures of the moon that were taken from the Williams Observatory telescope. Next, we'll bring in Muzhou Liu, class of 2013, who is a space operations engineer at SpaceX, which you may have heard of in the news lately. We're sending an all-civilian crew to space for 3 days, and we'll talk to Muzhou about his career in astronomy and hear from him about future lunar exploration. So first, a 2-minute explanation of today's holiday, the Mid-Autumn Moon Festival, or the Harvest Moon Festival. Many believe this harvest moon on the 15th day of the 8th month of the lunar year is the brightest and roundest of the year. This festival is observed in much of East and Southeast Asia, with a variety of customs that might include family gatherings, special foods, mooncakes, of course, and lanterns. An ancient Chinese legend connected with the festival involves a hero called Hou Yi, who shot down 9 of the 10 suns that were overheating the earth. He was rewarded by the goddess of the heavens with a magic immortality elixir that would enable him to ascend to the heavens and become a god. However, before he could take the elixir, Hou Yi's beautiful wife, Chang'e, drank it herself and flew to the moon along with a rabbit. That's a little random if you ask me. But one version of the legend is that the broken-hearted Hou Yi placed his wife's favorite foods on his table every year afterward on the day of the fullest moon, hoping she would appear. Other versions say this is the day that Hou Yi and Chang'e are allowed to visit each other on the moon. So now peek out your window at the moon if it's nighttime where you are, and on to testing your knowledge of the moon. So to work this trivia contest, you should take out your second device, go to crowd.live, so crowd.live, and then I'm going to share my screen so you can see the code that you should enter to play the game. It's Y like in yellow, 7, the number 7, S like in Seattle, X like in X-ray, and I like in igloo. So again, go to crowd.live, enter the code, and we're going to give people a few minutes to log in before the trivia game starts. And I have to say, once the trivia game starts, it might say that the first question is just a trial, but actually I would take it seriously because there are only 15 questions. I think they all count. The app might say they don't all count, but anyways, the code again is Y7, S like in Seattle, X like in X-ray, I like in igloo. So if anyone needs extra time, maybe tell me in the chat. Otherwise, we're going to start the. My daughter wants me to put the code in the chat, but it's on the screen. Everyone should be able to see it. And we'll get started soon. And of course, a reminder, no looking up answers. You can talk to the person next to you. That's okay. And the winner gets mooncakes from Chinatown. So if everyone's good, I think we might get started with the game soon. Yeah. Okay. Are we Zareli, I think we can go ahead and start, but here we go. Okay, so this is the first question. The way CrowdPro works, you get points for the speed and the accuracy of your answers. So it helps to be right and it helps to be fast in your responses. Every question is 30 seconds. Okay. What is the distance in miles between the moon and the Earth? Okay. Okay, 73% got that right. Okay, so far so good. Great. Okay, question number 2. If you weighed 120 pounds on Earth, how much would you weigh on the moon? £0, 20 pounds, 40 pounds, or 60 pounds? Okay. Good. So I think that means, okay, I don't know if anyone's gotten both the questions right. But, question number 3, how many people walked on the moon? A is 6, B is 12, C is 16, D is 24. Well, I don't have the answer key in front of me, but I guess I just look at the most common answer because people have been getting them right. Great. Okay, question 4. How often do blue moons typically appear? A, 22 to 3 years, B, 10 to 15 years, C, 30 to 32 years, or D, 50 years? Maybe we can ask Kevin what a blue moon is. Wow, everyone got that right. More than I can say when we tested this. Okay, great. Question is who got it fastest? Great. Okay, question number 5. What is the moon's atmosphere made of? A, oxygen, B, nitrogen, C, hydrogen, D, nothing. Wow, we've got a very knowledgeable audience here. 91% got that right. Very good. Let's see the ranking. So David J is ahead. Kevin's in second place. Question 6. How old do scientists estimate the moon is? A, 100 million years old, B, 800.5 million years old, C, 4.5 billion years old, or D, 10 billion years old? Great. Again, answer is 4.5 billion years old. Okay. David J is still ahead. Question number 7. Compared to the Earth, how big is the moon? A, about 1/10 of the size, B, about 1/4 of the size, C, about half the size, or D, twice the size. Who took this photo? Okay, this one tricked people for the first time. I think maybe that photo was not helpful. Okay, but David J is still in the lead. Question 8. How hot can the moon get when the sun shines on it in Fahrenheit? A, 0 degrees, B, 45 degrees, C, 140 degrees, or D, 260 degrees Fahrenheit. And now we're just about a little past the midpoint of the contest. Okay, 260 degrees. Well, I certainly cannot give away the answers because I forget all of them. Great. Okay, question number 9. What game did the Apollo astronauts play on the moon? A, tic-tac-toe, B, golf, C, checkers, or D, ping pong? No one chose ping pong. Okay, question 10. How far does the moon drift away from the Earth each year? A, 4 centimeters, B, 6 feet, C, 20 yards, or D, a mile, 1 mile? Okay, very good. Kevin's in first place now. Question 11. Which moon phase is right after the new moon in the northern hemisphere? A, waning crescent, B, waxing gibbous, C, first quarter, or D, waxing crescent? Okay, maybe we should grade based on whether you've taken an astronomy course. Sounds like some people have. Next question. Question 12. How much trash has been left on the moon? A, 200 pounds, B, 1.5 tons, C, 10 tons, or D, 20 tons? Okay, 2 people got that. Question 13. How does gravity on the moon compare to gravity on Earth? A, it's a quarter the amount on Earth. B, it's half the amount on Earth. Oops, typo there. C, it's 3/4 the amount on Earth. Or D, it's the same. Okay. Good. Kevin, with 9 out of 15 correct, is in first place. And question 14, second to last question. What phase is the moon in during a lunar eclipse? A, a new moon. B, last quarter. C, full moon. Or D, first quarter. Very good. Oh, Dennis has jumped into first place. Okay, last question coming up. Question 15. How many moons have been discovered in our solar system so far? A, 43, B, 61, C, 78, or D, 150? Great. Okay, final results. Dennis, class of 77, is in first place. Congratulations. Very impressive. 11 out of 15 correct with 842 points. David J in a close second. Okay, well, Dennis, if you can send a message to Virtual East, which is where Zarelli's at, with your contact information, we'll get you mooncakes. Congratulations. Very exciting. And so now we're going to turn things over to Kevin Flaherty, who's going to explain some of these answers and talk some more about the moon and show us some pictures. I'm going to stop sharing.
Yeah, thank you very much. And thank you very much, Xiaowei, for inviting me. I'm really kind of excited to be here virtually with all of you. So those of you that don't know me, my name is Dr. Kevin Flaherty. I'm the observatory supervisor in astronomy. So I kind of run the observatory last night, and this is great timing for this because we had our first observing night of the semester last night. So we had like the newest round of future EFA alums who were up at the observatory, and we were showing them the moon plus all sorts of other new Jupiter, Saturn, and it was wonderful. So it was absolutely great. So like Xiaowei said, I've got a couple of minutes of kind of talking about the moon. So I'm going to share my screen, share my presentation here. Okay, so I'm going to start off with this picture, which is actually a picture of the moon taken at our observatory in Williams College. We have a special telescope that's great for kind of wide field images, and it's perfect for the moon. We've got a number of images like this. So this is where I wanted to start. And going back in sort of the history of the moon, thinking back of kind of how people have been observing it over, many years and many centuries, basically people have been looking at the moon for as long as they've been looking up. It's one of the most easily recognizable objects in the night sky. So people have been looking at it for a long time. And some of the earliest recorded evidence of the moon goes back 5,000 years to kind of rock carvings in Ireland, where kind of it looks like kind of the phases of the moon people were starting to mark down. And even you go back to the kind of a 4th or 5th century BC, and astronomers in India and China and Babylonia were keeping track of the lunar cycles. They could start to predict solar eclipses and lunar eclipses and things like that. And then, it's then the first 1,000 years AD where people started to figure out, oh, the moonlight that we're seeing is actually reflected sunlight. It's the moon isn't producing its own light, it's actually reflecting from the sun. And then building from there is when we really start to get more detailed observations. And especially as we got into kind of telescopes became involved. So Galileo Galilei, kind of in his time, in the 1609, 1610, kind of pointing a telescope at the night sky and really kind of seeing what's going on. His some of these drawings from his Sidereus Nuncius, showing kind of different phases of the moon, really kind of seeing that the moon is not a smooth surface, that there are a lot of different objects up there, or there are mountains and valleys and things like that. And for a long time, these drawings became more and more complex. This is one from 1647, Johannes Favelinus. So really starting to study, what are the different objects in the moon, kind of tracking it over time and seeing what are the different features and things like that. And for a long time, it was drawings because that was what is available. But as soon as cameras came along, people started taking photographs of the moon. And this is one of the oldest surviving photographs of the moon from 1851 by John Adams Whipple. This is daguerreotype of the moon. And it was actually, so this is oldest surviving photo of the moon. There are older photos of the moon. Louis, I'm not going to pronounce his name correctly, but the namesake of the daguerreotype did take an image of the moon, but then his laboratory burned down a couple of months later. So we don't have that anymore, unfortunately. But, people have kind of built more and more photos of the moon, kind of grown with time. But one of the things you'll notice in all of these photos is they're all showing one side of the moon. And that's because, there's one side of the moon that faces us at all times. It's locked into place so that as the moon rotates around us, the moon rotates itself, and we always see one side. And it wasn't until we could send spacecraft to the moon that we could actually see what the other side of the moon looked like. So this is the first image of the far side of the moon taken by the Luna 3 spacecraft in October 1959. It's not the greatest photo of the moon, I would understand, but still it's, very advanced technology for the time. So now, that's 1959. So go ahead 60 years to today, and we've gotten a lot more advanced technology in terms of studying the moon. So this was the first image of the far side of the moon. This is what it looks like today. So this is an image taken by the Lunar Reconnaissance Orbiter, which was launched in 2009 by NASA. And it's producing some of the most amazing photos of the moon that we have to date. It's been scanning the entire surface. The size of a pixel on here is 100 meters. So, about the size of a building here on campus. So you can get really sharp features, really good detail on everything. And this is the far side of the moon. And now here's the combination of the near side on the left and the far side on the right. And these are, again, amazing detail that we can see in these photos. But one of the really big things that stands out is how the near side of the moon is so very much different than the far side of the moon. The near side of the moon, the side that we're familiar with, that's always facing the Earth, has these broad dark patches that are known as maria. And these are believed to be kind of crater impacts that broke through the surface of the moon and brought up this magma ocean, maybe 3 to 3.5 billion years ago. So kind of on the old side, but not as old as the moon itself, which was closer to 4.5 billion years old. So bringing that sort of magma ocean to the top kind of resurfaced everything, smoothed it out, and then cooled down over time. And that led to this sort of smoother surface. Whereas the far side of the moon didn't have that. So what you're seeing here is all the crater impacts that have built up over time. And we see so many craters from the entire history of the moon because the moon doesn't have an atmosphere at all, or it has a very, very small atmosphere. So any small piece of rock that's traveling through the solar system, of which there are many, especially early on in the life of the solar system, if it's flying in towards the moon, instead of burning up in the atmosphere like it does here on Earth, it's going to go down and it's going to hit the surface. So it's going to create craters. So if you look closely, there are craters on top of craters on top of craters from these many, many generations of meteorite impacts on the surface. The other thing is that since there is no kind of atmosphere, there's no weathering of the surface. There's no wind to kind of blow dust around. There's no water to sweep it up. So meteorites that hit the surface, 4 billion years ago and left an impact crater, we can still see some of those craters today. And the only thing that's going to get rid of that crater is more craters. So it's only after, you've built up enough craters that you can kind of cover up old things and create this sort of structure. So this, because there's no weathering, it also gives us this really pristine record of early on in the life of our solar system. It's really hard on Earth to find rocks that are 3 or 4 or 5 or 4.5 billion years old. But you go on the moon, and that's basically what you have around you is rocks that are 3.5 to 4 billion years old. Some are a little bit younger, but that's the majority of them. We talked a little bit about the distance to the moon and the size of the moon. So this is to help orient you. So this is obviously the Earth on the left and the moon on the right. And the size and the distance to them is to scale. So it gives you a sense that, first of all, space is big and empty, but also the moon is about a quarter of the size of the Earth, and how kind of that 250,000 miles stands in relation to the different sizes of the Earth and the moon. The moon being about 2,000 kilometers in radius, so about a quarter of the size of the Earth. And here's another nice one that I like. So this is taken by a satellite kind of on the other side of the moon looking down on Earth, kind of showing the moon passing in front of the satellite in front of the moon. And you can sort of see the relative sizes there really well. The moon is roughly the size of Australia in terms of kind of the diameter there. So so the moon has roughly a diameter of 4,000 kilometers, but the appearance of the moon does change with time. And this has to do with kind of the relative difference between how close the moon is to us or how far away it is. For the most part, it stays roughly 250,000 miles, but does move a little bit closer and a little bit further away. So that gives you things that we're familiar with, like hearing about supermoons, or maybe if you've heard of micromoon. And these, this nicely shows them side by side, where it does look significantly different when they're side by side, although in the night sky, it might be a little bit harder to tell if, it's been a month since you've seen a full moon. It might be hard to tell the difference, but there is, a small difference due to changes in the distance from the moon. Another thing that we are getting from, this is again from the Lunar Reconnaissance Orbiter, is getting a lot more detail about the topography of the moon. So these are maps of the height of different parts of the moon. It's the near side on the left and the far side on the right. And I put some reference points on the bottom for scale, so you know how big these things are. So here, you can really kind of see the difference between the Maria on the left, that's kind of like magma ocean leftover areas being a depressed area on the moon, kind of lower height. And then the highlands on the far side of the moon, which got their name because they are at a much higher height than the rest of it. And you can see a lot of the effect of the impact craters, where some of the biggest impact craters are severe depression in the center and then kind of peak at the rim on the outside. And that gives some of the largest features. And one of the things that also stands out here on the far side of the moon is that big blue spot at the very bottom of the far side of the moon. This is the Aitken Basin. So it's one of the largest impact craters in the solar system. And it just kind of dominates, it's not as obvious in the original image of the far side of the moon. Let me, I can't go back. If you look back at the far side of the moon, it looks like a little bit darker patch relative to the rest of it. Here it really shows up as much deeper. And we're talking about, 4, 5, 6 kilometers deep. So for reference, Mount Everest is 8 kilometers. So it's a very deep basin. So it's one of the largest impact craters that must have happened, early on in the moon's life and really just left this kind of huge dent within the moon itself. We talked a little bit about the gravity on the moon in the trivia contest. So we talked about what it does to your weight. I'm going to use a different reference point and say if you were an Olympic pole vaulter, you could pole vault over Thompson Memorial Chapel if both you and Thompson Memorial Chapel were on the moon. So that's because the gravity is about 6 times weaker on the moon than on the Earth, and that's in large part because of the smaller the smaller mass of the moon. So that really kind of helps the gravity. The kind of videos you've seen of astronauts bouncing around on the moon is all because of this lower gravity. the temperature on the moon. So the temperature, there are huge temperature extremes on the moon. It goes from very cold to very hot. But first, I want to set some reference points. So an average February day in Williamstown is about 0°C. We all know that it actually gets colder than that on the coldest moments in Williamstown, but this is about an average. It definitely gets below freezing in February and January and March and sometimes November and sometimes April and sometimes May. And then average July temperature of about 24°C. So that kind of gives you a reference point for how warm things are. The hottest temperature on Earth is about 60 degrees Celsius. I think this number is from the Libyan desert. I can't remember if Death Valley is past that at this point, but that's about the hottest temperature. And then the coldest temperature you'll see on Earth is about negative 88 degrees Celsius. And that's down in Antarctica, some of the research stations down there. And then the moon, the sunny side of the moon blows away the hottest places on Earth. It's up to 123 degrees Celsius. And that's in large part because there is no atmosphere to help kind of redistribute heat or block out some of the light from the sun, kind of ultraviolet rays. So all of that heat goes straight into the surface. And as soon as you're in the sunlight, you feel that heat. On the other side of that is if you're in the shade, it gets down to negative 248 degrees Celsius. Again, that's because of the lack of atmosphere to kind of retain some of the heat and distribute it around. So as soon as the sun goes away, the temperature drops very quickly. So you think of a typical kind of lunar day is about 27 days. So it really spends 13 and a half of those days at this 123 degrees Celsius, and then spends the other 13 and a half at negative 248 degrees Celsius. So it really kind of swings dramatically between those two extremes. But that's sort of, if you're at the, say, the equator of the moon, if you're at the North or South Pole, things are a little bit different because there you never see any direct sunlight. Unlike the Earth, which is tilted a little bit, which allows for the North Pole to be at some, spend some number of years or some number of months in sunlight and then some number of months in darkness, the North Pole, the moon is kind of more straight up and down. So the North Pole has a harder time of seeing any direct sunlight. So now this is a map of the maximum temperature on the moon, showing, again, I've kind of put the reference points for the hottest Earth temperature and the coldest Earth temperature here, and shows that there are these really cold areas that never actually get warm enough so that ice could melt. And this is really interesting because one of the things that people are looking for kind of in the future for the moon is there water on the moon? And they look at places like the North or South Pole and these craters to say, could there be ice water kind of buried in the moon up there? Could we look for it? And one of the ways you look for that is to kind of see, okay, what are the temperatures there? And has it ever gotten hot enough to melt ice water, to melt ice? And there are places on the North Pole of the moon where it hasn't gotten that warm. And here's a map from the moon, NASA's Moon Mineralogy Mapper. So this is a NASA instrument that was actually on top of an Indian spacecraft that went to the moon, and blue shows their measurements of where water is located. And again, it's we don't know if this is kind of small pebbles of water or big boulders, but it really shows that there's more water, there's likely to be water at the poles that don't see these wild swings in temperature. In terms of what creates the moon, it was a Mars-sized object that basically smashed into the Earth 4.5 billion years ago and just kind of sheared off some of the material and created this sort of proto-disk around the Earth, which then coalesced into the moon. And we know that from a lot of the Apollo missions, kind of studying the rocks, seeing age dating them, looking at their composition, and comparing it to the Earth, and finding a lot of similarities that suggested that a lot of what we're seeing from the moon is coming from Earth in this sort of impact, which would have certainly done a lot of damage to the Earth, but created the moon in the process. So I mentioned that we saw this kind of these features. We learned about the formation of the moon from the Apollo landings. And we talked in the trivia contest about how 12 people have walked on the moon. And what's really nice about some of the lunar reconnaissance orbiting images is they can do very high resolution images where you can actually see the material, that 20 tons of material that's been left over on the moon. So this is from the Apollo 14 mission. Here's the kind of lander, or what's left of the lander, kind of down there. Here's an instrument that they left behind, and you can see the trails, the walking trails, as the left behind by the astronauts walking between them. And for reference, there's, how long is Spring Street, to give you an idea of kind of how far they walked on the moon. Here's some images from the surface of the moon for the Apollo 14 mission. This is the one where they played golf on the moon. So, on the bottom left, there's kind of following the map. And on the upper right, you see kind of the broader terrain of what it was like at that landing site. Kind of lots of boulders, maybe kind of some hills and valleys, and that sort of thing, maybe some craters around, but really kind of a stark area on the surface of the moon. And then here's Apollo 17 on the top and Apollo 12 on the bottom, to kind of see more of these tracks. Apollo 17 with its moon buggy, you can see the tracks from that and kind of where they left it, along with the footprints and some other equipment. So we can still, we can see all these kind of this trash, the stuff that we've left on the moon is still sitting there. It's not going to go anywhere until meteorites kind of cleared out. But so we can still see all of these different things on the moon. So that's the sort of past with the moon. The future with the moon is getting really kind of interesting. And it's very different from the past with the moon. And I know Muzhou Lu is going to talk about this some more, so I'll just kind of quickly introduce some things. But when you look forward and kind of the future of the moon, part of the reason it looks very different from the past of the moon is because of the change of the people that are visiting it, kind of the entities that are visiting it. In the past, it was dominated, it was entirely, US and Russia sending rovers, and then the US sending people. And now it's expanding dramatically. So some of the upcoming things, so this one at the top is NASA is planning a mission in 2023. It's called Viper. It's the Volatiles Investigating Polar Exploration rover. It's a rover that's heading to that Aitken Basin on the far side of the moon, and it's basically going to drive around and look for water. It's able to drill kind of 2 meters down into the kind of surface of the moon to see if there's water buried underneath the surface. So it's going to look for that. The other part of this is private industry is really growing as a place to kind of go to the moon. And that's partly because NASA set up this Commercial Lunar Payload Services Initiative, where they're willing to pay commercial companies to bring some NASA instruments on the moon. So Astrobotic is one company, SpaceX is another one that's kind of doing a lot of these sorts of things. So they're looking at, can we launch something to the moon, and NASA will just kind of buy, or you could, I guess, if you wanted to, buy space on that spacecraft and then send something to the moon. And the other side of this is kind of the international side of this. It's not just the US and Russia. It's China, it's India, it's Japan, it's Germany, it's all sorts of different countries. So this is the Chang'e 4 kind of lander, which is the first lander on the far side of the moon, which is a huge technological accomplishment. And here on the left is a Lunar Reconnaissance Orbiter image of where the lander actually fell, kind of down here. There's a crater that Williams College could fit in for scale. And then this is what the lander looked like, and it had a little rover to kind of drive around as well. So when we look at sort of the future of explorations of the moon, China has a big program that they're planning. India has programs that they're planning. Japan, Germany, other countries are also kind of planning things. So it's really expanding what we're looking for from the moon. And there's a lot of different reasons for that, but I'll leave it there. And I think it's a good stopping point. So I will get out of this and I'll stop sharing. And so, yeah, so that was my kind of brief presentation of the moon. And I think now I'll turn it over to Muzhou Lu to talk about his career in astronomy and talk some more about what's the future exploration of the moon look like.
Hey, Kevin. Yeah, that's awesome. Thanks for sharing that. And I don't have slides prepared, unfortunately. And if you could keep some of the last couple of slides you have up, that actually would be pretty sweet. And yeah, I just want to say hello to everyone for joining. I'm really glad to see some familiar names in today's participants. And then also, I did receive messages from other fellows about this event. And I think they're probably in different time zones. And so, so this recorded event will be beneficial there. And, this is my shout out to all of them. And I think I have 10 to 20 minutes to talk to you all today. And then, well, particularly to share my astronomy experiences, with Williams, how what I studied and how everything turned out after I left. And I know I was recently introduced to Xiaowei, so she definitely has some questions for me later, but I really can't resist the opportunity to talk to everyone about some of the more recent and also future lunar exploration projects that Kevin already mentioned a little bit. And, I think this just will benefit everyone. If you go out and read the news and some exciting stuff pops up, you have a context in terms of, what is going on and what's the goal and why are we doing all these things. All right, cool, I'll get started. So yeah, Chang'e 4 is actually a really good one to pick up from. So in terms of the recent missions, so China actually had a really aggressive lunar exploration program for the last few years. So Chang'e 1 was really the first one. So both Chang'e 1 and 2 were orbital missions. So essentially when you go explore a new environment, you have to start by sending a orbiter going around the body just to map it out. So like the lunar reconnaissance orbiter that is used still to this day to map out the details on the feature and detailed features. Just so you essentially you have data, then you can then pinpoint what else you want to go and explore in depth. And so, the US has done this for decades, but China hasn't really done that until the Chang'e mission picked up. So the first two missions were wildly successful. They sent orbiters to go around the moon and collect data, and particularly images. And then Chang'e 3 and 4 were lander missions plus a rover. And the first one, actually in between, they also sent a Chang'e 5 test mission to test out how they would return a spacecraft with sample that they collect from the moon back to Earth. So that in space exploration, sample return is always the holy grail. How can you actually, without sending astronauts, how can you actually collect the sample from that planet back to Earth and study, right? For the Apollo program, there was a lot of effort put into returning lunar samples back to Earth. So the Chang'e mission actually did that with Chang'e 5, which only happened recently. You can kind of Google it and look at all the footage and exciting footage that that mission provided. You can see the whole the landing process, images they've taken, and then how the ascent module redocked with the return spacecraft. It's just incredible how much they've achieved in the last few years. So obviously they have more planned, including human missions, but I'll touch on that a little bit later. And on the India space program side, there are only 2 missions in, but they've already tried to do a landing mission there. So they sent the Chandrayaan-1 was an orbiter mission. And that was a pretty successful one. And for Chandrayaan-2, they planned for actually a lander, but it had some issues during the descent process. So I'm sure in the next few years, you will hear about the India lunar mission programs, and they will send these more Chandrayaan missions with their own rockets to explore the moon. So India's space program is very scrappy. It's notoriously, but also excitingly scrappy. There are images of how that space program picked up with engineers, carrying their rocket parts on the bicycles to get from place to place. It's a really, really exciting set of objectives they've laid out for the future. And then actually more recently, this is actually last year, the Israeli space program sent a small lander actually on board a SpaceX Falcon 9 rocket. So we launched it and we were all very, tied in with that mission. It was a good launch. We sent it to the moon. They did a good burn. So when you get to the moon, you have to decelerate the spacecraft aggressively, but accurately in order for it to be captured by lunar gravity. And then you can then pinpoint the exact burn that you want to make sure it can land exactly where you want. So they were doing really well until the very end, similar to the Chandrayaan mission 2. So hopefully they can pick up. It's always difficult with a smaller country with a smaller budget to finance these really lofty goals, but really hopeful that they will pick up and try again. So that's not some of the recent ones. Obviously, what's going on with the US. So Kevin pointed out that the US actually has an Artemis program. It's very similar, in terms of the ambition and effort to Apollo. We all know Apollo really well, but Apollo really was just, quite literally the moonshot program, just to send people to the moon, and it was politically motivated. But now we have this, NASA has this Artemis program that is very complex and interesting. It's design, and it's not just run by NASA, it's actually run alongside other commercial companies, including SpaceX. And the goal is to actually map out a structure with all the different infrastructures in place, such as like transporting, how to transport astronauts to a station. They call it the gateway, lunar gateway, that is orbiting the moon. So how do you do that? And then once the astronauts arrive there, they will then change their spacecraft to a lander, which is commercially provided to land on the moon. And then there will be also a series of logistic programs. Kevin mentioned the CLIPS, which is the commercial initiative to send cargo and other scientific instruments directly to the lunar surface. Actually, things like Intuitive Machine, Firefly, Maston, all these private companies popped up. They won the contract, and they're building these small crafts that actually, 2 or 3 of them are actually contracting SpaceX Falcon 9 to get launched to a lunar orbit. So that's sort of the recent effort, right? So looking at the future, many countries want to get into lunar exploration. And so that highlights the international collaboration and effort here, and then also a healthy dose of competition. So let's start with Japan. Japan actually has a private company called iSpace that's leading the effort. They have a very robust homebrewed, JAXA with their space mission and systems. They have a lot of experience with the LEO missions over the years. LEO is the low Earth orbit program. India, I already mentioned, you will hear about them in the news. Korea, actually, they want to get into the race as well. So they're building an orbiter that will be launched on the Falcon 9 pretty soon. China and Russia, they recently announced a collaboration, a design to build a lunar base. This is probably both the most shocking and then also the most anticipated effort in coming years, is how they will, essentially how multiple countries, international effort had collaborated and built the International Space Station. This is a collaboration of 2 countries to build a lunar base in competition with the Artemis program that NASA, alongside other, Italy, Japan, Korea, all these other countries signed up to develop. Very different design at this time. It's really interesting to see how they shake out, and various goals they want to achieve are also similar, but from an engineering side, super different. Very exciting stuff. UK, Mexico, they're also in on the race too, as well as the United Arab Emirates. And the UAE, they are similar to Korea. They want to launch an orbiter on a Falcon 9. I don't know why it comes back. But the UAE actually achieved a Mars orbiter mission just the last couple of years. Actually, the interesting connection there is I went to graduate school in University of Colorado Boulder, where the UAE, actually the government agency, worked with the university and the institute there to design and build the spacecraft that was launched, and it was a very successful mission that is currently orbiting Mars. With that, yeah, I think it's what we really want to anticipate in the next few years is, the Chinese program, the Chang'e 6 and 7. We'll see what those will bring. We want to see what these other countries that have not done it yet. We want to see what they want to achieve, and we really anticipate this big race that's going to happen between the collaboration of China and Russia, and then US, NASA, and the other ISS partners so far too, and what they will achieve. So that's just a brief highlight, and there's a lot more to talk about. I'm happy to discuss more in the Q&A session. And I think we can go back to Xiaowei to kick off some questions.
Yeah, great. We're going to have a Q&A now. So if anyone has questions, you can either put them in the chat or you can raise your hand and unmute yourself to ask questions directly. But first, thank you to both Kevin and to Muzhou. Those were fascinating presentations. I like the context with Williams College, and hearing about these up and coming programs is really fascinating. I thought maybe I'll kick it off with a question for Muzhou, although he just disappeared. It sounds like you've been working on the design of some of these programs, and I was wondering if you ever imagine going to space and sort of what your ideal mission would be.
Oh, yeah. Interesting question, definitely. Depends on the spacecraft. Right now, like where I work, the Dragon mission, the Dragon spacecraft has been wildly successful, and we've been flying very good missions so far. That would be a really fun one. Like if I have the budget, or if I win the lottery, quite literally, and get a seat, like that would be a no-brainer. I would definitely do it. But we're looking at these other more ambitious projects coming up. I'd rather stay on Earth right now and like help build out these newer spacecrafts and get them to fly everyone, many more people at a much lower price, and get them to space.
Good. Well, I'm sure we'll see SpaceX in the news more. Maybe a question for Kevin then. Can you tell us if there are any developments in the astronomy department at Williams, and sort of how the observatory is being used, and whether there are extra students there tonight? And I don't know if we got to the question about, is the moon the brightest and roundest tonight, or is that just part of the myth?
Ooh, that last one, I'm not entirely sure, but I can tell you about changes in the astronomy department. And the biggest changes within the astronomy department are the fact that for those of you that know Karen Quitter and Steve Souza, they retired 4 years ago. So that's 2/3 of the astronomy department retired. So I filled in for Steve Souza, and Professor Ann Jascott, who's actually an alum from the class of 2008, is now taking over the Karen Quitter role. So in that sense, we're kind of had a lot of turnover in the astronomy department, and the new part in the personnel, but otherwise, we're still doing a lot of really great things at the observatory. The telescope that has been up there since the 1990s is still going strong. The students used it last night, that sort of thing. And yeah, I think the other thing is dealing with light pollution in the area. Like Williamstown is considering putting LEDs in the town, so we have to kind of talk with them to make sure that the light kind of stays pointed down and doesn't stay pointed up at all, so that we can kind of preserve the night skies that we all really enjoy. So yeah, that's the update in Williamstown.
Thank you. So we have a question for Muzhou here from Michael Gao, class of 21. How do you predict private companies or government agencies will deal with space debris in the future? Will they attempt to remove debris?
Oh, yeah, I'll speak on my kind of just personal level and what I've been following. Well, first of all, it's really just a low Earth orbit problem. Right? If we're talking about lunar exploration, I guess we want to just maybe talk about all the trash that we left on the moon and how we might want to minimize that in the future. And it's going to require some kind of international agreement for sure. People in the field knows about the Space Act agreement that many countries signed back in the late 60s, and that we have to follow that kind of framework for future more advanced space exploration. And many people like in the industry are thinking about space debris in low Earth orbit, and it is definitely a problem. It's there every mission. It's always something we're nervous about and concerned about. So there is, some of the latest, if you read the article, some of the latest discussions are, should we have kind of the right of way rules? Actually, there isn't any right now. Really just, all the players in the field, whether you're government or your space private company, it's all just based on, goodwill and the best practice. But yeah, how do we actually regulate that internationally? Creating right of rule, kind of how we manage air traffic with operating spacecraft, that's one aspect. But debris cleanup is a huge effort. Actually, a lot of private companies are pursuing that goal, and you'll see that pop up in the future in the news as well. What this is, I think it's pretty exciting to see, and this is like definitely one of the things that is very prime for private companies to take on. Hopefully that helps.
I think that's a very comprehensive answer. I did see a private company pop up saying that they're going to help clean up with debris, and so I'm hoping we can look forward to more of that in the future.
Yeah, definitely.
We have another question from our trivia winner. I think this might also be for Joe on the international front. Is there an international legal framework in place governing how nations compete on the moon in terms of both unmanned probes and the manned missions from the US and from China and Russia?
Oh man, I guess that's for me. That's kind of a little bit definitely beyond my scope of expertise and authority to answer. It's more like, if this trivia we had a few beers that we can definitely talk in depth about it. But from this perspective, I guess right now there is no legal agreements yet governing how we cooperate in exploring space. Obviously, we want everybody to be open to each other in terms of their plan. Competition should remain healthy, obviously, and that will definitely drive more innovation and create a better outcome for everybody in terms of operating on the surface of the moon. And I firmly believe that's just a matter of time before we have bases on the moon. And yeah, for example, right, differences are, NASA is focused on having essentially a gateway that goes around the moon. That's more easily, that's more accessible from Earth. So you can launch a spacecraft and it will dock in orbit around the moon. And then you can essentially stage landing missions from there and go explore. So you don't necessarily have to build a very large base. Whereas Russia and China, their collaboration focuses on a very big footprint on the surface of the moon. So very different approach and concepts. And we should all follow that in the future. Like you will see these on the news as well.
Okay, again, a reminder, if anyone has questions, put them in the chat or use the raise your hand function, and we're happy to unmute you. But there's another comment, again, sort of on the political front. Please comment about the impact of US-China geopolitical relations on space cooperation.
Yeah, I guess I was partially answer that as well. Somebody commented the Artemis Accord, and that is definitely I would consider that like a political move in terms of, hey, we want to get more, right now we're just trying to posture like, oh, we have more partners here and there. So, it's sort of a response to the Russian-China alliance. NASA has reached out to partners and signed this Artemis Accord to define how they want to explore. But yeah, the previous question is still very pertinent. Is between these two entities, how will they collaborate going forward?
I have another question for Kevin. I was wondering if you could talk a little bit about the equipment that's at the observatory, what functions they can do, and lastly, is there any way for alums to get access to the observatory to see the night sky when we're in town?
Yeah, so here we have kind of a couple of different telescopes that we can use for our observing program. So there's our main 24-inch telescope, the one that was installed in 1992. And that's completely computer operated. It's sitting directly 4 floors above me right now. And if it were clear out, the students would be opening it up right now. But that's kind of the main one that we use for a lot of deep sky imaging, a lot of kind of advanced level projects and things like that. But in addition to that telescope, within that dome and attached to that telescope, we have a couple of extra telescopes, 3 of which are designed for looking at the sun, like at sunspots or solar flares or things like that. And one of them is actually a spectrograph that was built by a Williams student a couple of 10 years ago. That was their summer project. It was to build a spectrograph to look at the sun and really kind of disperse the light into the full spectrum. You can see the absorption lines and everything. So it's a really nice kind of legacy that the student left behind that we kind of continue to use going forward. In addition to that main observatory, we've got a couple of smaller telescopes that sit out on the roof. So kind of visual telescopes. One's a little over 2 inches, one's closer to 8 inches. And those are great for looking at kind of the moon or Jupiter or Saturn or Pleiades or anything like that. And they're really nice to kind of like looking through an eyepiece, look through a telescope, do something similar to what Galileo did back in the day, and kind of have that experience of what it's like to look through a telescope and really kind of see these objects with your own eye. In addition, we have a wide field telescope. So the one that the images of the moon that I showed, that has a wide field of view, kind of took that image of the moon. It's also good for bigger objects, kind of multiple galaxies within the field of view. Pleiades is also another nice one through that because it's a little bit kind of wider and a little bit too bright for our main telescope. And then outside of that, we still have our historic observatory, Hopkins Observatory. The first floor of that is still a planetarium. So we have planetarium shows regularly every Friday. We don't use the telescope that's on the second floor anymore, but otherwise we still have the kind of planetarium going. And in terms of alumni getting involved, right now during the kind of pandemic times, it's a little bit tough because we're not allowing kind of visitors into the buildings. But the best way in non-pandemic times would be for the planetarium shows, we allow kind of everyone to visit those. And if it's clear, we bring people at the planetarium show up to the observatory and we get to kind of look through the telescopes there and that sort of thing. Yeah, so that's the best way for alumni to get involved. But you can also just contact me if you're in town post-pandemic and you just want to like stop by and check out the observatory. I'm happy to give anyone a tour. I always like showing off the observatory, so I'm always happy to do that.
Great. Is another reason to hope for post-pandemic times. So we have another question for Kevin from Dennis again. Constraints of current research capabilities notwithstanding, what is your biggest question about the moon? What would you really like to know?
That's a really good question.
That question a little bit. Maybe at the end, if you can talk a little bit about your current research.
Yeah. So I think I could fold those two together. So my research area is all focused on planet formation. And in particular, I study the really kind of early stages of planet formation, where you have this giant cloud of gas and dust, and some little piece of it becomes kind of gravitationally kind of bound and collapses in on itself. And then you form a star at the center, and then you form this disk of gas and dust around it. And it's this disk of gas and dust out of which all of the planets form. So I study the kind of conditions within that disk. I use a radio telescope or an array of radio telescopes down in Chile to really study, what's the turbulent velocity within there? Are there any kind of outflows? What happens if there are 2 stars in the center of it instead of just one? How do you create sort of Tatooine type systems? And the moon formation is kind of a really interesting thing within that context, because those disks of gas and dust, we think typically last about 10 million years. And that's kind of sets the timescale for forming something like Jupiter. If you want to form a Jupiter-sized planet, of which we know there are kind of quite a few in our galaxy, you have about 10 million years to do it. But something like the Earth could maybe form a little bit afterwards. And maybe kind of 30 to 50 million years is what we know about kind of age dating the solar system, how long it took for that to form. But we don't really know from observations of other systems what that's like. And we don't know how common our solar system is compared to other solar systems. We know we're missing a type of planet that seems to be the most common type of planet around other stars, a super Earth. So why is that? And I think part of that might be related to sort of collisions and evolution over time. and this maybe this kind of either the first 10 million years or to the sort of 30 to 50 million year range when the moon formed. And the sort of collision that formed the moon, there are still questions about that. Like, where exactly did that object come from? Did it come from near the Earth's orbit, from further out? What was its composition? Those sorts of questions we don't fully know. And that's what I'd really like to know, is know more about how do we form the moon and what's going on there.
It really makes you think about time when you're talking about millions of numbers like that.
Yeah.
Thank you for that. I think those were all the questions we had today. I want to thank you both very much for participating and agreeing to talk to the alums and students and everyone on today. We will be sending mooncakes to Dennis. Hope you enjoy them. And thanks to everyone for joining. Happy Moon Festival. Hope you have some time today to go outside and take a look at the moon. I know it was beautiful in New York City last night. Hope you're somewhere where it's clear out to get a good view. So happy Moon Festival, everyone.
Yeah, thank you.
And thanks to Zarelli for helping us organize this and doing all the behind the scenes stuff. It's really critical. So, thanks to everyone.
Thank you.
Have a good night.
Thanks, Albert.